am Sambaraj, Assistant Professor, Institute of Aeronautical Engineering College. Today we are going to discuss about unit digit or last digit. This topic belongs to number system, one of the most important topic in a number system. Number system means properties of numbers. It is also called number theory. Properties of a unit digit. Before that, one example. Find the unit digit of 200 whole to the power of 200. Unit digit or last digit. Find the unit digit of 200 whole to the power of 200. In 200, consider only unit digit but not 10 digit, 100 digit. Those are negligible. Consider only unit digit. In 200, unit digit 0. Next to apply the power 0 power 200. We know that 0 power any number 0, then answer is 0. This type of questions belongs to unit digit concept. Next, this topic depending only properties of a digits. If you know properties of a digits perfectly, then this topic completed. Here there is no formulas here. Questions are based on only properties. Here properties of a unit digit. Here first case 1, only 3 cases exist. Case 1, 0 power n is equal to 0, 1 power n is equal to 1, 5 power n is equal to 5, 6 power n is equal to 6. Case 1 property 0, 1, 5, 6. The type of questions are given same number answer of unit digit. But n must be positive integer. Negative does not exist. If you apply negative, decimal value only exists. But here calculate only digit, unit digit. Then n must be positive integer. Here example based on first case. Find the last digit of 125 whole to the power of 125. In 125, calculate unit digit is also written as 5 to the power of 125. 5 to the power of n and 5 to the power of any number 5. Therefore, answer is 5. This is about case 1 property. Similarly, case 2. Case 2, 4 and 9. Here 4 and 9. Check the property of 4. Here 4 property. Here 4, 6, 4, 6. Cyclic repeated. Example. Case 2. 4 to the power of 1, 4. 4 to the power of 2, 16. Consider unit digit 6. 10 digit, 100 digit are not considered here. Next 4 to the power of 3. 4 cube 64. Unit digit only 4. And 4 to the power of 4, 256. Unit digit 6. A 4 property 4 and 6, 4 and 6 cyclic repeated. Cyclic repeated. 4 type of questions are given. Then check the power even number and odd number. When power is an even number, that answer is 4. When power is an even number, answer is equal to 6. Example. Find the last digit of 124 whole to the power of 124. 124 whole to the power of 124. Same method is also written as 4 to the power of 124. Next 4 to the power of even number. 124 is an even number. 4 to the power of even number 6. Therefore, 124 whole to the power of 124, last digit is 6. Similarly, second sub point in case 2, 9. Here 4 and 9 following same condition, same property, same logic. 9 also, 9 to the power of 1, 9. 9 to the power of 2, 81, 1. Yes, 9 to the power of 2, 1. 9 to the power of 3, 9. 9 to the power of 4, 1. 9 property also, 9191 cyclic repeated. And also check the power. When power is an odd number, unit digit 9. When power is an even number, unit digit 1, respectively. One example based on this logic. Find the last digit of 729 whole to the power of 728. Is also written as 9 to the power of 728. 9 to the power of even number, 728 is an even number, 9 to the power of even number 1. This is about second case in unit digit concept. Here 4 and 9 completed, 0 completed, 1, 5, 6. Pending 2, 3, 7, 8. That is called case 3. Case 3, cyclicity only important to unit digit. You have to implement only cyclicity. That digits are depending only cyclicity of a number. Here first one, 2 unit digit property. A 2 unit digit property, 2, 4, 6, 8. These numbers are only cyclic repeated. Here case 3, first one 2. A 2 to the power of 1 is equal to 2. Next 2 to the power of 2 is 4. 2 to the power of 3, 8. 2 to the power of 4, 16, 6. 2 to the power of 5, 32, unit digit 2. A 2 property, 2486, 2486 cyclic repeated. Similarly, 3 property also. A 3 property using same logic, 3971 cyclic repeated. 7 property, 7931 cyclic repeated. 8 property, 8426 cyclic repeated. Case 3, each number, 4 numbers are cyclic repeated. This is about case 3 property. Example, case 3, find the last digit of 22 whole to the power of 11. But directly, sir, 2 power 11, that method 2 power 1 is equal to 2. That method it is not correct. Here technique, a 22 whole to the power of 11 is also written as 2 to the power of 11. Consider unit digit only. 2 property, 4 numbers are cyclic repeated. Then power divisible by 4. 11 divisible by 4. Consider only remainder. Remainder only 3. Here 4 into 2, 8. 4 2s are 8. Remainder 3. Divisible by 4 indicate 4 numbers are cyclic repeated. Then divisible by 4. Here next apply the power 2 to the power of remainder. Where remainder is equal to 3. 2 cube is equal to 8. Therefore 22 whole to the power of 11. Unit digit is 8. Method, when this problem depending only remainder, when remainder is equal to 1, first term of the repetition. When remainder is equal to 2, second term of the repetition. When remainder is equal to 3, third term of the repetition. When remainder is equal to 4, fourth term of the repetition. But using divisible by 4 condition, 4 remainder not possible. When remainder is equal to 0, answer is last term of the repetition. Last term of the repetition. This is about first example, case 3. Next, similarly, find the last digit of 7 to the power of 1, 2, 3, 4, 5, 6. Second example, find the last digit of 7 to the power of 1, 2, 3, 4, 5, 6. Is here apply divisibility rule of 4. 4 divisibility rule. Last 2 digit of a number is divisible by 4. Then the total number exactly divisible by 4. Here next 7 divisibility condition. 7931 cyclic repeated. Where 4 numbers are cyclic repeated, then power divisible by 4. But here 7 to the power of 1, 2, 3, 4, 5, 6. Consider only last 2 digit of a power. Just you apply only 4 divisibility test. Next 56 divisible by 4. Reason 7 unit digit property. 4 numbers are cyclic repeated, then power divisible by 4. 56 divisible by 4. Here 14 into 4. 14 into 4. 14 into 4 is 56. That is exactly divisible by 4. A remainder is equal to 0. Remainder is equal to 0. When remainder is equal to 0, consider power assumption is equal to 4. But this problem 7 to the power of 0, 1, that is exactly correct. But others not equal to 1. A 2 and 8, 2 to the power of 1, 2 to the power of 0, 8 to the power of 0. 2 and 8 unit digit property, 1 not possible. In unit digit topic, when remainder is equal to 0, then power assumption 4. When remainder is equal to 0, consider power assumption is equal to 4. That is 7 to the power of 4. 7 to the power of 4 is equal to 1. Therefore, answer is 1. This is about a second example in case 3. Similarly, last example, then concept of the topic completed. Here examples are depending only these logics. If you know these logics perfectly, then unit digit concept completed. Here next last, find the last digit of 888 all to the power of 1, 2, 3, 4, 5, 6, 7, 8, 0. But question lengthy, but apply only logic of the topic. If you know logic of the topic, then this example easy. Here find the last digit of 888 all to the power of 1, 2, 3, 4, 5, 6, 7, 8, 0. Is also written as 8 to the power of 80. Power consider only last 2 digit of a number, that is 80. 8 property also for numbers are cyclic repeated, then power divisible by 4. 80 divisible by 4. Remainder 0. 80 exactly divisible by 4. 4 into 20, 80. When remainder is equal to 0, then power assumption 4. That is 8 to the power of 4. 8 to the power of 4 is equal to 6. In general, 8 unit digit property in bracket, 8 to the power of 1, 8. 8 to the power of 2, 4. 8 to the power of 3, 2. 8 to the power of 4, 6. 8 to the power of 5, 8. Just multiplication. Each term multiplied by 8. Suppose 8 into 8, 64 unit digit. 8 into 4, 32 unit digit. 8 into 2, 16 unit digit. 8 into 6, 48 unit digit, and so on. Each case is divisible by 8. Just consider only unit digit but not 10 digit. But here remainder is equal to 0. This example, remainder is equal to 0. When remainder is equal to 1, first term of the repetition. Remainder 2, second term of the repetition. Remainder 3, third term of the repetition. Remainder 4, fourth term of the repetition. But fourth term of the repetition, that is not possible because divisible by 4. Remainder less than 4 only possible. 1, 2, 3, 4, 1, 2, 3, 0 only possible. When remainder 0, answer is a last term of the repetition. 8, 4, 2, 6, last term of the repetition only 6. Therefore, answer is 6. Here answer 6 only correct. This is about case number 3. Once more, unit digit properties. Case 1, 0, 1, 5, 6, same number when n must be positive integer. Case 2, 4 and 9, check the power, even number and odd number. Case 3, 2, 3, 7, 8, each property for numbers are cyclic repeated, then power divisible by 4. Consider only remainder. Note, when remainder is equal to 0, then answer is last term of the repetition. This is about concept of the topic. Next sample questions. Number 1. Find the last digit of 120 whole to the power of 1 plus 121 whole to the power of 121, 125 whole to the power of 125 plus 126 whole to the power of 126. First target, calculate individual unit digit. Next to apply the operator addition, subtraction, multiplication, division. But this question belongs to only addition concept. Here next method, here 120 whole to the power of 120 also written as 0 power 120. Next to place 121 whole to the power of 121 is also written as 1 to the power of 121. Next 125 whole to the power of 125 also written as 5 to the power of 125. 126 whole to the power of 126 also written as 6 to the power of 126. First calculate individual unit digit. In next 0 power n, 0 power anything 0. Next 1 power anything 1. Next 5 power anything 5. 6 power anything 6. Next to apply the operator addition. A 0 plus 1 plus 5 plus 6, that value is 12. But 12 option D is not correct. 12 10 digit and unit digit. But problem belongs to only last digit. In 12 last digit only 2. Therefore answer B only correct but not D. But 12 that option also available. Don't confuse. A target only unit digit but not 10 digit. Calculate only unit digit, that is only correct answer of the given problem. Your first question answer B only correct. Okay, right. Next. Second example. Find the unit digit of 32 whole to the power of 37. In 32 whole to the power of 37, just you apply only 2 property. A 2 property is also same as 2 to the power of 37. In next 2 property for numbers are cyclic repeated, then power divisible by 4. 37 divisible by 4, consider only remainder. Remainder is equal to 1. That is 2 to the power of remainder. When remainder is equal to 1, 2 power 1 is equal to 2. Then answer A only correct. Answer is 2 only correct. Therefore 32 whole to the power of 37, remainder is 2. Okay, right. Next, third example, number 3. Find the last digit of 47 whole to the power of 47. 7 unit digit property is 7931. 7931 cyclic repeated. Then power divisible by 4 is also written as 7 to the power of 47. Next 47 divisible by 4. Here 4 into 11, 44. Remainder only 3. Next 7 to the power of remainder. When remainder is equal to 3, 7 cube 343. In 343 unit digit only 3. Option C. These questions are depending only properties of a unit digit. Case 1, case 2, case 3. Unit digit topic depending only 3 cases. Important concept only case 3. That models only important. First concept same number. Second concept even and odd number. Third concept cyclicity. That model only important. Next fourth example number 4. Find the last digit of 88 whole to the power of 88. Option A 2, B 4, C 6, D 8. Here 88 whole to the power of 88 is also written as 8 to the power of 88. Similarly, 88 divisible by 4, remainder is equal to 0. We know that when remainder is equal to 0, then power always consider only 4, assumption only 4, but not 0. Therefore, a to the power of remainder, when remainder is equal to 4, 6 only correct. 8 property, 8426, 8426 cyclic repeated. A to the power of 4 only, 6 only correct but not 1. So remainder 0, 8401, 8401, that is not possible in 8 property. Then this question answer again option C only correct. Next, fifth example. Important. Find the last digit of 44 whole to the power of 44 into 53 whole to the power of 53 plus 79 whole to the power of 79 into 87 whole to the power of 87. Option A 1, B 3, C 5, D 7. First calculate individual unit digit. Next to apply the operator. Here first one 44 whole to the power of 44. 44 whole to the power of 44 is also written as 4 to the power of 44. 4 property, check the power, even number, odd number. Even number, here 44 is an even number. 4 to the power of even number is 6. Second, number 2, 53 whole to the power of 53 is also written as 3 to the power of 53. 3 property, for numbers are cyclic repeated, then power divisible by 4. 53 by 4, remainder is equal to 1. 13 into 4, 52, remainder only 1. Here next to 3 to the power of remainder, 3 to the power of 1 is 3. Second number is 3. And next number 3. 79 whole to the power of 79. 7 to the power of 9 to the power of 79. 9 to the power of odd number is 9. 9 to the power of even number 1. 9 to the power of odd number 1. 9 to the power of odd number 1. Even number 1. And last one 87 whole to the power of 87. 8 to the power 7 to the power of 87. 7 property, for numbers are cyclic repeated, then power divisible by 4. Consider only remainder. 87 by 4, remainder only 3. Next 7 to the power of remainder. 7 cube 343. Unit digit only 3. Next to apply the operator. A 44 whole to the power of 44, unit digit 6 into 53 whole to the power of 53, unit digit 3. 79 whole to the power of 79, unit digit 3 into 87 whole to the power of 87, unit digit 3. Then next to multiplication, 6 into 18 plus 9 into 3, 18 plus 27, 45. But the unit digit in 45, unit digit only 5. Option C only correct. Easy concept using only properties. There is no formulas here. This is only shortcut method. Next, example number 6. Find the last digit of 1 to the power of 1 plus 2 to the power of 2 plus 3 to the power of 3 plus and so on 9 to the power of 9. This example only important because covered all the properties here. Option A 1, option B 3, option C 5, option D 7. Your next method, calculate individual unit digit. Here first one, 1 to the power of 1. Here 1 to the power of 1 is equal to 1. Next 2 to the power of 2, 2 square is 4. Next 3 cube 27, unit digit 7. Next 4 to the power of 4, 4 to the power of even number 6. Or 4 to the power of 4, 256, unit digit 6. Here next 5 to the power of any number 5. Next 6 to the power of any number 6. Up to 6 easy. Simple calculation. Here next 7 to the power of 7. Next 7 property for numbers are cyclic repeated. 7 by 4 remainder only 3 but not quotient. 4 into 1 4 quotient 1 remainder 3 consider only remainder. Here next 7 cube 343 unit digit only 3. 7 to the power of 7 unit digit is 3. Next 8 to the power of 8. Again 4 numbers are cyclic repeated. Then power divisible by 4. Remainder is equal to 0. Then power assumption only 4. That is 8 to the power of 4 only 6. Here next similarly 9 to the power of 9. 9 means check the power even number or odd number. 9 to the power of odd number 9. 9 to the power of odd number 9. Here next to apply the operator 1 to the power of 1 1, 2 square 4. Next 3 to the power of 3 7, 4 to the power of 4 6, 5 to the power of 5 5, 6 to the power of 6 6, 7 to the power of 7 3, 8 to the power of 8 6, 9 to the power of 9 9. Here next to apply the operator simplification part. Here 1 plus 4 5, 5 plus 7 12, 18, 23, 29, 32, 38, 47. Sum is 47. In 47 unit digit only 7. Option D only correct. This model very important to placements and also competitive exams because covered all the properties of a unit digit. Next, seventh example, number 7. Again important. Find the last digit of 1 factorial all to the power of 1 plus 2 factorial all to the power of 2 plus 3 factorial all to the power of 3 and so on 100 factorial all to the power of 100. Option A 1, B 3, C 5, D 7. A method using factorial. Here n factorial means definition of factorial. N factorial, n into n minus 1 into n minus 2 into and so on 3 into 2 into 1. Example 5 factorial, 5 into 4 into 3 into 2 into 1 is equal to 120. Next 0 factorial is equal to 1. 1 factorial is equal to 1. This is about definition of factorial. But this problem using factorial symbol notation. First one 1 factorial. Calculate individual unit digit. First one 1 factorial. 1 factorial 1. 1 to the power of any number is equal to 1. First one. Next 2 factorial all to the power of 2. 2 factorial is equal to 2. 2 square is 4. Next to 3 factorial all to the power of 2. 3 factorial 3 into 2 into 1. 3 into 2 into 1 6. 6 to the power of 3. 3 factorial all to the power of 3. 6 cube 216. Unit digit only 6. Next to 4 factorial. 4 factorial all to the power of 4. 4 factorial 4 into 3 into 2 into 1. 24 power 4. This is also written as 4 to the power of 4 only 6. Next 5 factorial. Here 5 factorial all to the power of 5. 5 factorial, 5 into 4 into 3 into 2 into 1, 120. 120 all to the power of 5. Here 0 power 5, 0 power anything is equal to 0. Similarly, 6 factorial all to the power of 6. 6 factorial, 6 into 5 into 4 into 3 into 2 into 1, 720. 720 all to the power of 6 is also written as 0 power 6, 0. Similarly, 7 factorial all to the power of 4. 7 factorial, 7 into 6 into 5 into 4 into 3 into 2 into 1. Unit digit of a 7 factorial 0. 0 power 7, 0 power anything is equal to 0. Therefore, 7 factorial all to the power of 7, unit digit 0, and so on. 8 factorial, 9 factorial, 10 factorial, up to n factorial. Remaining all these numbers, unit digit 0. 0 power anything is equal to 0. Is 7 factorial, 8 factorial, up to 100 factorial. Unit digit is always 0. Here note 5 factorial, 6 factorial, up to n factorial. All these numbers, unit digit is equal to 0. Here consider only up to 4 factorial only. Up to 4 factorial only. Here 1 factorial is equal to 1. 2 factorial all to the power of 2, 4. 3 factorial all to the power of 3, 6. 4 factorial all to the power of 4, 6. And 5 factorial 0. And so on up to 100 factorial 0. That part negligible because 0. Here next to apply the operator. 1 plus 4, 5. 5 plus 6, 12. 5 plus 6, 11. 11 plus 6, 17. And next 0, 17. In 17, unit digit only 7. Therefore, answer is option D only correct. Option D only correct. Okay, right. Next note, using same technique, example, note example, find the last digit of 2 to the power of 100 factorial. These two questions are belongs to factorial concept. Find the last digit of 2 to the power of 100 factorial. But two property, 4 numbers are cyclic repeated. If 4 numbers are cyclic repeated, then power divisible by 4. Power divisible by 4. Here power is 100 factorial. 100 factorial divisible by 4. 100 factorial divisible by 4. Consider only remainder. Here in a 2 property, 4 numbers are cyclic repeated. Then power divisible by 4. 100 factorial divisible by 4. Here method, here 4 factorial. Here 4 factorial is equal to 24. 24 exactly divisible by 4. Remainder is equal to 0. Next to 5 factorial. 5 factorial 120. 120 also exactly divisible by 4. Remainder is equal to 0. And so on up to n factorial divisible by 4. n factorial divisible by 4. But when n is greater than 3, remainder is equal to 0. Indirectly, 4 factorial, 5 factorial, 6 factorial, 7 factorial, and so on up to n factorial. All these numbers are exactly divisible by 4. Remainder 0. When remainder 0, power assumption only 4, but not 2 to the power of 0, 1. 2 property, 1 is not possible. 2 property, 2486, 2486 cyclic repeated. Here next, here remainder 0. Here 100 factorial by 4, remainder 0. 100 factorial by 4, remainder 0. When remainder 0, power assumption 4. That is 2 to the power of 4 is equal to 6. This is also important by using factorial concept. Note n factorial divisible by 5. That cases remainder 0 when n is greater than 3. But n is equal to 1, n2, n3. The type of questions are given. You check individual remainder. but greater than 3, that all remaining all numbers remainder 0. When remainder 0, power assumption 4, 2 to the power of 4 only 6 but not 1. This is about factorial concept using unit digit concept. Okay, right. Next, 8th example. Find the unit digit of the expression 4 plus 9 to the power of 2 plus 4 to the power of 3 plus 9 to the power of 4 and so on 9 to the power of 100. Option A 4, option B 6, option C 9, option D 0. Method. First you divide two parts, alternative series 2 parts. First part 4, here 4 to the power of 1, next 4 to the power of 3, next 4 to the power of 5 and so on 4 to the power of 99. This is first series. Next second series, 9 to the power of 2 plus 9 to the power of 4 and so on 9 to the power of 100. You divide two parts, 4 and 9. 4 odd number, 9 even number. We know that 4 to the power of odd number, 4 to the power of odd number 4, 9 to the power of even number, 9 to the power of even number 1. Notation. In next 4 to the power of odd number 4, next 4 to the power of odd number 4 up to 99 times, up to 50 terms only. Total 100 terms, here 4 50 terms, 9 50 terms. 9 to the power of even 1, 9 to the power of 4 1 and so on 1 only because power is an even number. Up to 50 terms, 9 50 terms, 4 50 terms. Next to apply the operator, here 4 plus 4 plus 4 plus up to 50 terms, here 50 into 4 200, 1 plus 1 plus 1 up to 50 terms, 50 into 1 50, here sum 200 plus 50 250, in 250 unit digit 0, then answer D only correct. 8th example, answer is 0. Here series method, here alternative series, 4 and 9 check the power, even number, odd number, 4 to the power of even number 6, 4 to the power of odd number 4, 9 to the power of even number 1, 9 to the power of odd number 4. But total 100 terms, in 100 terms 4 50 terms and 9 50 terms. Next calculate sum of this equation. Here 50 into 4 plus 50 into 1. Total sum 250. In 250 calculate only unit digit 0. Therefore answer is option D only correct. This is about unit digit concept. Total 10 digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 10 digits. If you know these 10 digits properties perfectly, then last digit concept completed. There is no formulas here. Apply only shortcut methods. Shortcut indicate properties of a unit digit. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.